Here we're going to continue our discussion of shared work problems. And there are two things we have to distinguish between. The first is what we call shared time, and the second thing is we call individual time. Now shared time is just that. It's the time that two parties work together on a problem. And individual time is how long it takes each individual to complete the task. Now, in the previous video of shared work problems, we solved for shared time. Here, we're going to be thinking about the individual times. Now, it turns out individual times are closely connected to individual rates. That's going to be an important connection for us. So for example, if you note that it takes an individual independently 3 hours to complete a task, then their rate is 1/3 of the task per hour. So that's going to be the connection between individual time and rate. If you know how long it takes the individual to complete a task, the rate is 1 over that time per unit that you're talking about to complete the task. Okay? So with that in mind, let's take an example. Alright, so a landscaper and her assistant construct a garden bed. It takes the assistant 6 hours longer working alone than it takes the landscaper working alone. Working together, they can build the bed in 4 hours. How long does it take each person working alone? Okay, so I clearly see this as a shared work problem, right? Because I see that they have constructed this garden bed together. And when you have a shared work problem, you set up this little table. So in this table we have 2 rows. We have one for the landscaper and then one for her assistant. And we also have 3 columns. One for the rate, one for the shared time, and one column for the fraction completed. And I like to start filling in these tables by thinking about what we know. And reading the problem again, I see that the only real concrete information they give us is this. Working together, they can build the bed in 4 hours. Now, do you think that's shared time or individual time? Well, clearly shared time, right? Because they say working together, they can build the bed in 4 hours. Now that means shared time, right? This box right here, or the square, represents the shared time for the landscaper and the shared time for the assistant. Now these are always the same because the times are shared. So the shared time for the landscaper is 4, and during that time the assistant works as well, right? So the shared time is 4 in both cases. Notice in this problem that we know the shared time, and what are we actually looking for? Well, how long does it take each person working alone? Here we're looking for individual times. Now there's no square that mentions individual time, but there is a square that mentions rate. And from what we talked about a moment ago, rate is very closely connected to individual time. Okay, let's first identify what we're looking for with variables. So let's say, okay, how long does it take each person working alone? So let's let x represent the landscaper's time working alone. So the x is the landscaper's time to complete the job working alone. Now you could write y for the assistant's time, but is the landscaper's time connected to the assistant's time? Let's read the problem again. It says it takes the assistant 6 hours longer working alone than it takes the landscaper working alone. Oh, okay. So if the landscaper takes x hours, then the assistant takes what? Well, 6 hours longer. So that would be x plus 6. So that's the assistant's time. And the advantage of doing this, the advantage of not introducing a second variable, is that you won't need 2 equations. You only need 1 equation because you only have 1 variable. So I knew that if I called the landscaper's time individual time x, the assistant's time is 6 hours more than that, so it would be x plus 6. Okay, now you can't just take these expressions and substitute them into any of the squares, right? Because these are times. They don't represent rates themselves, nor do they obviously represent fraction completed. But what is the landscaper's rate if you know the landscaper's time? Well, as we discussed a moment ago, it's 1 over the time, right? So if this was like 5 hours, the rate would be 1/5 of the job per hour. In this case, it's going to be 1 over x. That's the landscaper's rate. And likewise, what do you think the assistant's rate is going to be? Well, it's going to be 1 over the assistant's individual time, which is x plus 6. Okay, and as before, to get the fraction completed, you simply multiply the rate by the shared time. So the fraction completed for the landscaper is going to be 4 over x, and the fraction completed for the assistant is going to be 4 divided by x plus 6, right? Because it's 4 over 1, and then you multiply those fractions together. Okay, so now when we create an equation, just like before, when you add the two fractions completed, you have to get 1, because one complete job, or one job has been completed, one whole job. So the equation we're going to get is this, that 4 over x, the fraction completed by the landscaper, plus the fraction completed by the assistant, is equal to 1, one whole job completed. Okay, so let's solve this equation on another page. 4 over x plus 4 over x plus 6 is equal to 1. So when we solve rational equations, remember the key thing is finding an LCD and multiplying both sides by the LCD to clear those fractions. So in this case, the LCD is going to be x multiplied by x plus 6. Right? So both sides by that. Now you can view that as over 1 on the left-hand side. Now because it's addition right here, we have to distribute, right? So it gets distributed. And first the x's cancel, and so it's going to be 4 multiplied by x plus 6. And for the next one, the x plus 6's cancel, so it'll just be 4 times x. And the right-hand side, we can multiply these together and get simply x squared plus 6x. Okay, now distributing the 4, we get 4x plus 24 plus 4x is equal to x squared plus 6x. And combining like terms on the left, 8x plus 24 equals x squared plus 6x. Okay, now we're solving a quadratic equation, right? So our strategy is to get everything on one side. I like to keep the coefficient of the x squared positive, so I'm going to subtract 8x and subtract 24 from both sides. And that's going to give me 0 is equal to x squared minus 2x minus 24. Okay, now let's write that in the following way. X squared minus 2x minus 24 is equal to 0. So just so you know, it's not uncommon that people go straight from this step to that step. Often people skip writing this step, so they mentally just jump right from there to there. Okay, so when you do that, you now that the right-hand side is 0, you factor the left-hand side. So let's do that. We get x minus 6 times x plus 4. And now solving the we solve the equation by setting both of these factors to 0. So x minus 6 is 0, or x plus 4 is equal to 0. So that leaves us with either x is equal to 6 or x is equal to negative 4. Now remember, x represents the landscaper's time. So the landscaper's time can't be negative 4, right? In other words, the landscaper can't save time in her life by creating a garden bed, right? She can't gain 4 hours. So the landscaper, it takes her 6 hours to create this bed. So let's write that down. The landscaper takes 6 hours to do this individually, right? Working alone. What about the assistant? Well, the assistant took 6 hours longer than the landscaper working alone. So the assistant would take 12 hours individually to create this garden bed. And together, they can do it in 4 hours. Okay, so that's how you deal with a shared work problem when you know the shared work time, but you're looking for the individual times. Until next time.